Well, welcome. Thanks for coming today. My name is Christine, and we're going to be talking about two-factor authentication. Since we're in London, I wanted to make sure I had a classy pun title, so we're going with A Tale of Two Sides of 2FA. Now, in the US, this talk actually goes by something that's slightly less classy. That's WTF 2FA, why you don't protect me. But I thought I would save the memes. So, what I really want to work on learning today is to really understand two-factor from a user perspective as well as from a developer's perspective. How you can secure your own accounts as well as securing your users' accounts. All the different 2FA types out there so you're not limited. As well as, how to protect our users, potential testing steps for our InfoSec people, as well as some best practices around actually implementing 2FA. And things I don't want you guys to worry about during this talk. Don't worry about having to take a ton of pictures. I'll have the slides up. I actually have a takeaway blog post up on my website, so you can kind of refer back to those. As well as there's no stupid questions. So at the end, if you have anything that you would like to dive into further, I'd be happy to answer. So, I'm obviously not up here to talk about London, and I'm not up here to talk about Paris. That's the Dickens quote. But I am up here to talk about users and developers. So, let's talk about a story. You are the owner of the coveted Instagram account @awesome. You're going about your day, being awesome, enjoying a little bit of avocado toast, think about posting it up on your Instagram, when all of a sudden, you get a text. It's from your mobile provider. It says something about your phone getting restarted, some SIM card gets updated, and then it restarts itself. You try booting it back up, and then you call it. It doesn't ring. You try restarting it, because that fixes 90% of the problems with your phone, but it doesn't fix it this time. What in the world just happened? So let's take it back to the beginning, when we first signed up for Instagram. So, we get to the login screen, we're pretty jazzed. You see, Awesome is still available? Hell yeah. So you sign in, you give it some password, a little bit about security. So you turn on 2FA. You are already given the phone number, do a text, it's gonna protect it, we're good. And then you go about gaining your 80,000 followers through, arty selfies and shadow pics. During that time, somebody was quietly coveting your short and sweet Insta handle. And what did they do? Well, they called up your mobile provider. They were able to use a little bit of social engineering, say from the last time you had a Capital One credit card breach. During that breach, what information was out there? Well, you had your full name, your address, and some juicy stuff like your social security number and your bank account. So that's easy enough to get T-Mobile to think that is you. And they're able to say, I lost my SIM card, as one does with an embedded chip in your phone, and I need a new one set up for it. Can you set it up for me? Of course, we can help you with that. And then that phone number that used to call your phone is now hooked up to someplace else. It's just a short, hot jump and a skip to get through your easily identified password, and that text message, where's that going to? Certainly not your phone. So this is just another view of kind of what happened with that adversary, the hacker, and us. They're able to game the system with the customer service representative here. This is a tweet just from January 10th from Arvind. He is a researcher at the Princeton University, and he was able to do this research for the past, for 6 months, looking into the mobile providers, the top 5 ones from the US at least, on how they are vulnerable to the SIM jacking, the SIM card hijacking that just happened to us. Every single mobile provider is vulnerable in slightly different ways. And so, unfortunately, our mobile providers aren't really geared to protecting our data. This is a quote from Reddit. Back in 2018, they had a hack where their admin got SIM card jacked, just like what happened to us. This was a huge hack that happened to Reddit. And it was something that just happened to us. They learned, as well as we're going to learn, that SMS two-factor authentication is not a means of securing your account. So let's take a step back. Let's all get on the same level. What is authentication? Well, it's just the process of verifying that you or someone, something, is who they say they are. So this is usually your username and password. And this is a direct quote from OWASP. These people know a little bit about security. But then when we're talking about two-factor authentication, what are those different factors? Well, one factor is the knowledge, i.e. our password. And then you have your second factor. Well, it could be some other method choice. It could be maybe something you possess. This could be a soft token or token. And we'll talk about all the different ways and method types here in a little bit. And then another way that you can have your second factor could be your identity, something you are. But then out there, you might see a lot of other acronyms around there with 2FA, two-factor authentication, 2SV, two-step verification. This is the Google flavor of the exact same thing. MFA, multi-factor authentication, 2 or more different ways, which is always 2 ways. It could be more, most of the time it's 2. Or 2F, which is a lazy way of saying two-factor authentication. So here are our TLAs for right now. But we had two-factor authentication enabled. At Awesome should be totally secure. What happened? Well, in our case, it was because we were making use of SMS two-factor authentication. When we no longer had our phone number, it was no longer in our possession. It could no longer be our second factor. What's another reason why two-factor authentication doesn't help our users? It could be because it wasn't even enabled. Adoption rates of two-factor authentication are awful. Back in 2018 at a conference, a security researcher from Google released what their adoption rates were of the Google's two-step verification process. Does anyone want to take a guess at what they were?
5%.
What?
5%.
5? 7? It was a little bit higher, not a ton. It was right at 10%, a little bit under, 9.7. And did anybody go to Stefan's talk on EVE Online on Wednesday? Yeah, it was a great talk, loved it. Everybody should check it out. But what happened is they were working on increasing their adoption rate of getting people to opt in to 2FA. Do you know what they worked up to? 10%, with massive amounts of user experience testing and flexibility going there, and they still only got up to 10%. So knowing this, let's kind of dive into our different method choices, and then we'll try tackling how we can increase that amount of users to opt into it. So SMS two-factor authentication, aka our old friend, aka somebody who let us down. So this is the most common two-factor method type because it's the easiest to use. If you have a phone and a phone number, you can do SMS two-factor authentication. Unfortunately, it's also the most compromised two-factor authentication type. And it hasn't been recommended by the National Institute of Standards and Technology since 2016. But it's still the most common. And if it wasn't bad enough, what we already know about SMS two-factor authentication, the signaling system number 7, so this is the backbone to every telecom network, actually has inherent flaws in it and exploits that you can kind of use to intercept text messages. So there was this group of white hat hackers, and they were able to compromise a Coinbase, a Bitcoin account, that was tied to a Gmail account that had that two-step verification process on it just by knowing the name, email address, and phone number. So let's figure out all the different ways that we could hack SMS two-factor authentication if we wanted to do it right now. First one, we could do the SIM swap, aka what just happened to us. This is also known as SIM hijacking. What you do is call into the mobile provider, use a little bit of social engineering Swap one SIM card for another SIM card. Number 2, port out scan. Pretty similar. So you call up the mobile provider, use your social engineering skills, and you're able to port your account from one provider to one that's maybe more friendly to you. Next up, we could do a brute force on the application itself. So if there is no rate limiting on the login or rate limiting on the verification code input process, we know what is a verification code usually? 6 to 8 digits. We could hack that with a cell phone. That's not much processing power that needs to really happen there. So we could just do a brute force on the application itself. Or we could, if we want to put in a little bit more time, we could do exploit the SS7 weakness. So we have options. Next up, we got TOTP. So that's time-based one-time password, also known as app-based or soft token. It has lots of names. And so you might know this more by which application you actually use for with this TOTP. So Authy is a common one, Google Authenticator, 1Password. Did I name, is that the majority? I don't know. Is there any other ones out there that I haven't named? What? LastPass? Oh yeah, I forgot LastPass. I should totally update that.
It was a Microsoft one as well.
A Microsoft one? Oh, okay. Any one that you guys love that is not up here? Yeah, nobody loves 2FA TOTP applications, but they're usable. And so this one is kind of an HMAC-based algorithm is used to do a symmetric private key that's generated for your server, and then it's put over on the application. And so with those, how you usually get that shared symmetric private key from the server over to the application is through the use of QR code, because nobody wants to make a user have to type in 8 characters or 10 characters or 12, however many that shared private key is. Next up, we got push-based. This one you might see more associated with Mac products. I know iCloud makes use of this. So you have your certain authorized device, say your MacBook Pro. You have a new iPhone that you want to log into your iCloud account with. It will do a push notification to your MacBook Pro to say, hey, somebody's trying to log in. Should you allow this or not allow this? And then you press allow, and then you're able to log into iCloud on your phone. The problem with this one is users kind of get trained always to click allow, and then when they have that invalid attempt happen, they just click it without even realizing what they did. So this one can have its drawbacks, but it does have its benefit that it's not visible when the screen is locked. Well, sometimes phones default text messages to displaying when the phone's still locked. Next up, we got email. So this one, you might consider quite convenient, but it's also a little bit controversial that does it actually constitute a second factor? And because it doesn't really fit in the soft token, it doesn't really fit in with the possession, it is a second possession, but sometimes email addresses are also used for your initial authentication, so is that a second authentication? And so this also should only be used with verified email addresses. Should you be sending a verification email to a place that you're not even sure if your user's using? It's less common, and you also might not see it referred to as second factor or 2FA. You might see it just referred to as OTP, one-time password. And then last up, and by far the most secure, is token-based. This is physical keys that can authenticate. They're usually physical, actual devices that you have to hold. This here is the Google Titan key, but the other most common is the YubiKey. I know Amazon has a ton of like do-it-yourself ones, and there's other options out there, but Titan Key and YubiKey are definitely the big players with these physical tokens. And so what these are, it's usually a USB drive, and then some sort of near-field technology. So I'm talking NSF or Bluetooth. And then with these, they actually make use of a universal second factor. So this is public key cryptography instead of that shared symmetric private key cryptography. But Let's kind of look at that one-time password versus universal second password, or as I like to kind of call this slide, the battle of the TLAs, three-letter acronyms. So, OTP versus universal second factor. OTP, the user actually has to physically type in the code. Maybe you're using something on your desktop and you don't have to physically type it in, but you do have to get that code from the application into whatever the verification server. You also have the setup and provisioning time. So when you have to have the user opt in to that process, they have to, then get onto the app, as well as there's always setup involved with it. In addition, the secrets are kind of stored in a single point for attack. So your server has to actually store that shared secret key, and it usually has to be stored in the clear. So that's never good to just have a single point of attack. Well, with the universal second factor, the user actually has the physical device, or hopefully has the physical device and hasn't lost it. If it's YubiKey, I think they suggest you get 2 or 3 or 4 at one time, so hopefully you would still have the YubiKey. This also has that strong cryptography through the public key cryptography going on there. And usually no personal information is associated with that token. So, knowing what we know now, we know our method choices and everything, what would we change? Some ideas for securing your account could be, first off, that initial authentication always make use of a long password or passphrase. I know this is something that we could constantly talk about, but why we constantly talk about it is because it's still a problem. Secure your second factor authentication with a different authentication method, aka don't use SMS. If they offer any other choice, try to make use of that. So we've learned that our mobile providers aren't good at securing our data and our phone numbers. So if that phone number is vulnerable data, should it be out on the internet? Is that something that we should be using for logins? Is that something that we should just let out? That's something that should kind of be considered a little bit more private data. If you have a phone number that's tied to a mobile provider, maybe think about on the internet not using that phone number. Make use of a VoIP, have it route over to your phone number. Don't reuse passwords. Did anybody go to Troy Hunt's talk, the pwned things? Yeah, we all know about what reuse of passwords causes. Don't do it, because I loved with Stefan's talk from EVE Online that they actually have their users go through that pwned API to check if that bin range has, with the hash, could be vulnerable. So they're actually applying that extra step to check for their users and give it to them. But it just helps with that the additional authentication, so you can help encourage your users not to reuse passwords. So we know mobile providers not so secure. If they provide any additional security, opt into it. So do that PIN on your account. Do that extra password. Whatever kind of like more secure means you have with your mobile provider, that helps add friction to help prevent those SIM card jackings, to prevent that account hijackings. And then hopefully you can keep on being ad awesome. But wait, what's up? Now we are developers at JiffyGram, an Insta rival. We're totally gonna take them on in. And now we know there's a lot of bad stuff out there. How can we protect our users? Well, first up, I know everybody says this about like usability and like accessibility and everything, but security is everybody's job. So, it's us as developers, it's us as designers, infrastructure and managers. InfoSec shouldn't be the only one who has to think about security. If you're coming to this talk, it's probably because you care about security. So it's something that we do need to keep in mind. Hopefully this might look familiar. So has anybody heard about the Ring and Nest hijacks that have been going on hacking lately? This is just from in December. So these are IoT cameras that were set up with pretty poor passwords, didn't have 2FA enabled, and hackers were able to get in and look and talk to people's kids. This is because the developers didn't have a strong password policy. They didn't enforce two-factor authentication here. This is something as developers we don't want to happen to our users, and it's something that we can be empowered to help protect from it. So now we know why it is important, and we have seen in the news why it's important. So let's take it back to our security basics. So we talked about that you should have a strong password as a user, but how can we encourage our users, now that we're the developer, to have strong passwords and strong passphrases? It's all through the password policy that we craft, and we'll walk through that here in a little bit on how we can help out with that. Don't make users have to rotate their password unless you have a good reason. Having frequent password rotation actually encourages for lower quality passwords. If they are showing up on, have you been pwned? Yeah, they should change their password. But if you'd want to do it for some arbitrary reason, like we want you to do it every 25 days because it's more secure, is it really secure? Like, challenge if somebody is telling you that. Store your hashes securely. So, is it a good thing to store our password in the clear? No. Is it secure to store it encrypted? No, because encryptions can be decrypted. But what about hashes? Hashes are one way. So they cannot be decrypted. They are more secure. And we'll dig into how we can make those even more secure. And then, does anybody work with credit card data here at all? Okay, do you know PCI standards? Are they a pain in the ass? Nobody wants to deal with PCI standards if you don't have to. So make sure whatever data you're storing in the database, it's important and has a real reason. Don't store extra data because inevitably there probably will be a data breach. And if you minimize what data you're storing, that's that much less data that will get out. Everybody knows this comic. Who loves Xkcd? I know I do. Okay, I love this comic because it is a great way of showing what makes a strong password and what makes a weak password. And it's all about entropy. So, but why does this help? At first, I thought it was because it was long. But the thing is entropy is not just about length. It's also about randomness. And so why that actually worked with the 4 words is it was long, but they were also random and not connected to each other, as well as not connected to the service. So greater entropy actually means it's a harder password to brute force. And passwords, we want them to be hard to guess, but easy to remember. Does anybody else think that that's a big contradiction? Because I think every password policy considers that a contradiction. They usually go for the first one. And so having that combination of extra length and randomness means you will have a higher entropy in your password, which means it's more secure. So let's test this out. So this is a website that's Interactive Brute Force Password Calculator. Perfect name. And so let's test a common password. So test 1, 2, 3. How long is going to take us to brute force maybe with somebody's phone? Not very long. So we're talking 35 seconds with crappy hardware. Now, let's look at a passphrase maybe. So, correct horse battery staple. Just took it out of the air. And what could this be? Well, we got a little bit more time with 100,000 trillion centuries. So, makes it a little bit harder there. So, when we're talking password policies that you as developers can do for your login process, let's try this out. This is GitHub. Everybody have a GitHub account? Yeah. So, the thing is maybe you didn't really linger on the screen when you were doing your GitHub account, but it actually has a very nice, secure, and flexible password policy. So they have a minimum length, but do you see a max length there? It doesn't. I was going through it. It was about 80 or 90 characters before it topped out on me. It'll still let me do it. So by allowing for the length and by not limiting the character set, they have a very high likelihood that their users are going to have high entropy passwords. But let's look at something that's maybe not as secure. Does anybody have a LinkedIn account here? LinkedIn, maybe it's more of a US thing, maybe, yeah, we got LinkedIn. This is 6 lowercase a's. That was a valid password. Does that seem like it would have a high entropy? No. Somebody's crappy cell phone could actually hack that one. This is Pandora. I know we don't really expect too much out of our streaming services. This also has a crappy password policy. Do better than Pandora and LinkedIn, people. Now, let's talk a little bit about password hash encryption. I'm not going to get into the math on this. We're just going to go super high level. There's tons of articles and resources out there if you really like that, because password hash encryption is actually pretty interesting. But what it is just an algorithm that takes data in and it produces a fixed size output. No matter how long the data that you get in, it's always going to be the same size output. And the thing with it, some hashes are stronger than others. So, MD5 SHA-1. You think that's a good hash? No, that one's that's been inherently broken, and I think it's been broken a while. And this is what they use for, like, if you hear rainbow tables and stuff. So that's like all known hash that could occur, and they just kind of run it against that. So they don't really need to know the actual password. They just need to know the generated hash. But something more like in the SHA-2 categories. So we're talking at least SHA-256, 512. These are considered more secure. It'll take a lot longer. I know, secure-ish. And so, but if possible, really what you want to go for and reach for in our modern technologies and when we're doing new kind of features is to go with an adaptive one-way function. So these are the recommended functions from OWASP. So that's the Web Application Security Professionals, something O. And so head over there, they'll tell you why, but just think of the strong adaptive functions as hash encryption with Flare. So they add, that you have to do this hash, but then they add some little extra bits around it on like how long it takes, how big it is when it's done, and it's just something that's inherently more secure. So reach for one of these. There's implementations in pretty much every tech stack. But wait, one of our users lost their phone, or they don't have had their app get deleted, or maybe they lost their token. It's pretty easy to use those physical tokens. So how can we help our user get back in? That's what verification codes are for. These recovery codes will help you out and allow access to the application again. These are usually shown once, and then they're not shown again because they're stored securely as a hash. And then what they usually do is allow for a bypass on the verification code. Ideally, you don't want to also bypass the password step. It should just be a help on the two-factor authentication. So, some two-factor implementations, lessons learned here. You have 2 routes when you're doing two-factor authentication. You can do the do-it-yourself route, or you can go the buy route. Either way, you're going to pay. You're going to pay with developer time, or you're going to pay with cold hard cash. So just figure out, what you're going for, what functionality you need, and what your business owner kind of wants out of it. If you have a shorter time frame, you might want to go with the buy route. It's going to take a little bit of time to get it right. So if that's not on your side, maybe you need to buy something. There's quite a few different options out there for two-factor authentication vendors. The big 2, though, definitely are the Okta and the Duo. And if I've had anything from just trying to scan around and look at the API documents on these things, I would go with Okta. These people actually care about developers and have a lot of transparency going on there. But if anybody's had a good Duo process and been able to do that implementation well, I would love to hear about it. So, if we're talking about rate limiting, whether you are in your buy solution or if you're in your actual, do-it-yourself solution, one thing to keep in mind is rate limiting is the key to preventing brute force attacks. And what a brute force attack is just trying to get logged in until it works. And with this, you want to stop your user from doing invalid login attempts after a certain amount of time. And what you can use instead of, or in addition to, is a truncated exponential backoff algorithm. But what the hell is a truncated exponential backoff algorithm? Well, it's actually quite easy. This is the approach that allows you to, when you have an invalid login attempt, you make the user wait, maybe a second, some odd seconds, before they are allowed to log in again. Then the next time they get an invalid login attempt, you wait that much longer. If they do it again, you allow for more time. So that's the truncated exponential backoff algorithm. If you learn how to say that really well, it sounds smart. But it's just something that is actually fairly easy to implement. So I'm a Ruby programmer. Anybody else do Ruby around here? No? There's not too much of us. But it's nice. We're free of semicolons. We don't have very many brackets either. It's lovely. Okay, but what it is it doesn't have to be hard to do the exponential backoff. You can actually add it into the rate limiting really easily. So when you have a retry, you just make it sleep for a while, or you make it wait before you allow the user to retry again. When we're talking about optional security practices, users don't like to opt into those for some reason. So you really need to make sure you think of your user base, you think about how your application is used, and try to get user buy-in to this. Make sure that you take your user experience into account. So this is another great example from Stefan's talk on Wednesday on the EVE Online. They found that a lot of their users actually had multiple accounts, or several hundred accounts. And so they want to get people to opt into that two-factor authentication because they didn't want to have to do that with every single account. So what they eventually did to kind of still get people to opt into the two-factor authentication is to have that shared secret key across the user's accounts. So thinking about that user flexibility while you're doing your implementation can help with your buy-in. And so with your users, you want to make sure it's easy to opt into that two-factor authentication. It's easy to add it, as well as they know where to go to find the two-factor authentication. And that you want to make sure it's flexible, so you take your user experience, how your users use your application into account. So this is, I might be slight but biased too. I, at Flywheel, went through and did the two-factor authentication that we had on the team. And so one of the things that we took into account is to make sure it was very visible for us. It was right underneath the account. We also made sure that how you could change it, how you could reset it, how you could manipulate it, had a very well laid out user flow. Now, I'm suggesting don't do what these people are doing. They don't have two-factor authentication at all. Do you see anybody up there that you would hope would have two-factor authentication? I see a lot of people. American Express, shame on you. Come on. It's a credit card processor. It's a credit card company. How can you not have two-factor? Do you think they care about security? I have an American Express. I'm worried about that one. When you are doing your do-it-yourself approach, you have to make sure that authentication is enforced in all pages. So this is kind of an additional authentication step, and you might have to take into account if whatever internet-facing pages you have, that you have to, like at the root, make sure it's going through that approach. You also need to kind of ask yourself, when do I want my users to re-auth? Should it be every 30 days? Should it be when they log in from a new IP address, new geolocation? This is like stuff that you have to consider that maybe isn't part of like the business analysis when you go into enable or start doing that two-factor authentication. And so that's something that you might have to do as a business trade-off with your business unit, or it's something that maybe you start with OneWay, do some user testing, and see what works from your users. When you are editing or removing these two-factor credentials, you want to make sure you ask for the password again. Because unfortunately, this could also be a part of a man-in-the-middle attack, and so disabling that two-factor authentication would just make it that much easier for the hacker to get in the account. So you need to add a little bit of friction here. If your authentication does fail, whether it's your password authentication or it's your verification code authentication, you want to make sure you're generic in your user, the error that you display. So look at something like this. This is nice. Does it tell you what went wrong? No. It's not something we like as developers while we're in development mode, because that's not helpful for debugging. But it's also not helpful for a hacker writing a script to figure out what to do next. Now, all of these are descriptive. They're wonderful as a developer. I like these as a developer. I bet hackers like these too, because it makes their job a lot easier. So let's not do that, at least not in production code. And one thing to also consider, this is an additional security step. Are we doing everything we can to protect our users? Are we making sure that we're also trying to keep our users in mind here? This is a tweet from Alice Goldfuss. I think it was just 2 days ago. I was looking at this. She was talking about how she was advocating for less friction with our users. But the problem is two-factor authentication and our security steps inherently are all about friction. We're adding friction for hackers, and we're trying to help protect the accounts. But unfortunately, if we can't even get users to opt into it, is it really protecting them? Or is it just always adding a hassle? So that's one thing to really think about your user experience, so that you take how your users use your application into account, so that you can balance that friction with how they use their account. And with your users, so I'm talking your super users, your admin users, those people with the most amount of privilege, two-factor authentication should not be optional. It should be a requirement. And if possible, give them all some YubiKeys. Give them the tokens. That is inherently the most secure approach. So, knowing all that we know now about two-factor authentication, it can help, but there's a couple things that we definitely need to keep in mind. It can only help enhance an already secure software that has secure password practices going on there. And some 2FA methods are a little bit more secure than others. So, I want to leave you with this. Friends, don't let friends use SMS two-factor authentication. So thanks for having me in DC, London. All the organizers and volunteers, thank you so much. I work for a little place called Flywheel. If anybody is looking for a job, we do remote happiness engineers in the US. Check it out. As well as, what questions can I answer for you? Anybody got anything? Any comments?
The balance on the kind of security for usability, that one where you're saying the generic failure for, I don't know if it's the user, if it's the email address or the password is wrong. Like, that's always a tough balance there.
It is.
Like, because that one's a particular one where it's like, I can't remember which email address I used for this, and it's like, it's not telling me whether it's got the wrong password, and it's like, not helping me with any of that. Whereas, a combination of potentially the backoff for brute force should mean that actually you should be able to tell the user, no, we don't have that registered address. You haven't registered, it must have been the other email address I used instead.
And that's true, but that also does provide more information for the hackers.
Absolutely.
And so this, what he was asking was a comment on those errors that you display and making it more generic, that it provides for a worse user experience. And that's one thing you can actually help. What helps is a user experience designer there, and that maybe what you're displaying instead of username if it's always an email address, help prompt your user by saying email address instead of username. Like, don't make them guess with that kind of stuff. Like those small prompts to help with in front, so they don't always hit that rate limit. And that's at what point you can do some user experience testing. Because like maybe you all constantly have people who always hit like 3. So maybe you set your rate limit to 4, because that still helps prevent a brute force attack. You know, kind of work with how your users are making use of that application. Then you can kind of find the patterns, and then you can stick your security right before, you know, you get to the balance of how users use your account and how they use the application over what they would be experiencing with a hacker and somebody who might be trying to infiltrate them. And like, you have to find that balance there. And don't just like have some rigid policy that you only have 2 times to log in, that's it. People are going to hate your application if that's it. Anything else? Well, oh yeah.
What are the options for recovering? So you had those recovery codes, but those are probably lost as well.
Okay.
The clear thing would be to just send an email for reset a password.
Yeah, well, if you want to go the reset password route, that is also a typical route that hackers love if it's too easy. That's one of those places that you have to do the kind of add the friction there too. So if a user has lost their recovery codes and has lost their initial like authentication device, yeah, it's at that point you should have it, you know, either escalate to support so that they have to do some actual physical verification there, or you can go through your password reset process. But then that's a point of, you know, hackability there, that if it's really easy to reset your password, hackers are just going to go around your 2FA and reset passwords.
Yeah, exactly.
Yeah. So like that reset the password, you know, maybe you have a cooling off time on it. But then, you know, anytime that your user can't get into the application, they're not using the application that you could use money. So that's why security is such a balance, and like you really have to kind of take that user experience into account too. And so it's what is the acceptable risk?
Yeah.
Yeah, sorry, there's no right or wrong answer in that one. It's as much security as you can apply with not pissing off your users.
Yeah.
Which is usually the answer to most things. Hi, what's up?
So what do you think on the passwordless approach? So just using something that you own, or just using a time key or a YubiKey, essentially?
What do I make use of?
So what do you think of the passwordless approach? So no password, so just using something.
Oh, that's something that somebody brought up the other day. So the no passwords, that you just make use of like two different factors. So like a YubiKey and then like maybe another personally identifiable details, or like a TOTP.
Well, yeah, you could just use the single. So just having let's say the tiny key.
Yeah.
With the fingerprint.
I think that's an interesting concept, and it's kind of hard, I think, to get away from that username and password. It's like ingrained in us as users in the login experience. Like, what is logging in if you don't have a username and password? I like the idea, but how many people have YubiKeys?
Well, I mean, it's Apple Pay, is it?
What?
Yeah, Apple Pay.
Yeah, oh yeah, like Apple Pay. Doesn't Apple Pay have some vulnerabilities out there too? Then that's the combination. So that's why, you know, like the 2 factors are supposed to help enhance security. So if you inherently go down to 1 factor again, and it's not username password, that's still only 1 point. And so yeah, like I think it's one of those that you have to still stay balanced, and like that initial authentication, like username password's been working a while, but if there's something else that comes up, I think it would be interesting too. Yeah, what?
What my bank has is they have an app, and it's Android, and my Android has a fingerprint sensor. So if you've installed the app and allowed it, you can log into the app and then say touch your fingerprint, and then it lets you in. So the idea is you've logged into your phone, which is one thing, and you put your fingerprint on there, which is the other thing.
Yeah.
And it's very convenient for me. I don't know whether it's a little bit vulnerable, that kind of answers that question about no user and password each and every time, because it's the device plus the fingerprint.
Yeah, and that is considered 2 factors of authentication there. But question, how long is your initial password? Is it a 4-digit code?
The original password? No, it's a you know.
It's unlocking your phone.
So that if I'm not using the app, so if I'm on the PC, say,
Yeah.
using the web thing, then you have to put in a full password, you have to put in another security.
Yeah, but on your phone, how do you unlock your phone? Are we talking passcode? How do you unlock your phone? So that's your first initial authentication.
Yeah, exactly. So you unlock your phone,
Yeah.
then
Yeah.
fingerprint.
Yeah. So now you're talking 2 biometrics as your 2 factors of authentication.
Where you get the physical phone.
That's true. That's true. You do have that kind of, it's the possession.
One and the fingerprint to get into the phone and then to get into the app.
Yeah. Yeah, it's definitely considered to be easy, and it's great user experience. We'll see what kind of hacks are going to be out there for that.
Well, yeah, chop off my finger.
Be alive.
You heard about the iris one and something to
Oh yeah, the iris is interesting.
from long away and use the photo of the eye. I heard another case of a key, like a physical key. Some thief from a long-range telephoto took a photo of the key and manufactured the key and got
What? Now that one's interesting, because like even if you take a picture of the YubiKey, the YubiKey's not going to work.
I'm talking about a physical key, like a traditional
Oh,
locking key.
okay. What's your question?
So, YubiKeys and the authenticator apps, they are not as accessible to less tech-savvy consumers as SMS OTP. So
Yes.
is there an emerging alternative that would apply to a wider, broader audience?
I think, right, I've seen, what his question was, is he was asking and saying that the TOTP as well as the token-based authentication are less user-friendly for for people who have accessibility issues, correct? And so I agree, and that are less tech-savvy, I think was one of the things. And so I think that's why we've been seeing a lot more biometrics going on there. The biometrics, something that you are, people are a lot, they know how to do a phone scan. They know how to hold it up and do their eye. And so that's something that I've seen a lot more. And I think people are adapting to have that as kind of one of the second factors. But you still you need either an application or, a fairly fancy phone in order to do some of those. But I've been seeing it's become more accessible to do kind of the biometrics type thing. Like the bank account, being able to go in with your thumb scan.
You're pretty down on SMS as a second factor.
I am.
But all of the attacks you suggested involved a fair amount of time and effort for someone to actually go and do that work to get into my account.
The SS7, I would say yes. That one is definitely a lot more effort. So he was saying, I'm fairly down on SMS two-factor authentication, and that some of those attacks do take time. Yes, they definitely do take time in order to get there. And yeah, SIM card swapping and hijacking take time, but it's not a hard thing to do, and it's definitely something that's been in the news even very recently. And so it does take time, and I do suggest if you only do have SMS two-factor authentication on your application, to at least enable that. Yeah, it adds friction, and it's better than nothing.
So I guess my point was going to be, if someone's that determined to get at me, I probably have bigger problems. Maybe
Well, the thing is that maybe they're not personally attacking you. You're just a phone number and a list to them. If you make it a little bit hard, they'll just go on to the next person. Which hopefully is not, one of us, but, somebody else that hopefully has two-factor authentication enabled. Well, thank you so much for coming today, and enjoy the rest of your conference here.